Hello dear students, good evening to each and everyone. All of you are welcome back on Wallah English channel. In this course, we are studying signals and system in comprehensive manner, and we are studying classification of systems. Already in this chapter, total we completed 27 lectures, and this is lecture number 28. Okay, this is lecture number 28. And the topic name is classification of systems. This is part 2. Yesterday just we have started how to identify whether the given system is linear or non-linear. Today we will see first of all, tell me, am I audible properly? Audio and video both are clear to you people? Yes or no? Okay, yes. Shall we start? So let us start with linear and non-linear system. So yesterday we completed this topic, linear and non-linear. Today we will see time variant and invariant system and causal and non-causal system. Okay, tomorrow I will finish this chapter, and from next week, so not tomorrow, Monday I will finish chapter, and then we will start the second chapter. So let us start, guys. Classification of systems. Today we will see this is completed. Now next is time variant and time invariant system. So let us continue time variant and time invariant system. What is the time variant and time invariant system? Okay, a system is said to be time invariant if its input and output characteristic does not change with time. Okay, so here it is written, system is said to be time invariant if its input and output characteristic does not change with time. That means, suppose if there is 2 seconds in delay, then there will be 2 seconds in output also. Okay, if input is delayed by 2 seconds and if output also delayed by 2 seconds, then it is known as time invariant system. But suppose if input is delayed by 2 seconds and output is delayed by suppose 1 second or 3 seconds or other than 2 seconds, then it is known as time variant system. Okay, so see, suppose, say for example, let us consider this is one system and this is input, and in this system we are giving this input initially, a rectangle pulse between 0 and 1 with amplitude 1, and this system produces this type of output. Suppose, just example. Now let us consider if this input signal is delayed by 1 second, this is x of t, and delayed by 1 second means x of t minus 1, and if output also delayed by same 1 second, then it is known as time invariant system. See, this is y of t, and for this input we are getting y of t minus 1. So this is y of t minus 1. So input is delayed by 1 second and output also delayed by 1 second. Okay, then the given system is said to be time invariant. Is this clear? Tell me in the comment box. Nikhil Misra, tell me, is this clear to you? Yes or no? Okay, now the procedure, how to check whether the given system is time variant or not. So let us see the procedure. Suppose system y of t equal to transformation on x of t, transformation x of t. Transformation on x of t. So first find output due to delayed input. First of all, find output due to delayed input. So delayed input means what? X of t become simply, delayed input means x of t simply minus t naught. Suppose input is delayed by t naught second. Remember this thing, here I am not replacing t with t minus t naught. Simply minus t naught you have to write in bracket of x of t. Simply write minus t naught. Again I am telling, I am not replacing t with t minus t naught. I am not replacing t with t minus t naught. Simply minus t naught you have to write, and find the output due to delayed input. This is the output due to delayed input. Let us consider y of t, output due to delayed input. Again I am telling, here I am not replacing t with t minus t naught. Simply you have to write minus t naught in the input. Okay, so this is output, the response or output due to delayed input. Okay, now find the delayed output with the same shift t naught. Find the delayed output. So next is yb of t, that is delayed output. Y of delayed output means t minus t naught. This is what? Delayed output by the same shift t naught. So here is y of t and here t minus t naught. So left hand side here t become t minus t naught. Right hand side also everywhere you have to replace t with t minus t naught. Everywhere you have to replace t with t minus t naught. See here this t become, in this equation this left hand side t become t minus t naught. So right hand side also everywhere replace t with t minus t naught. So this is the delayed output. What guys? Delayed output, delayed by t naught second. Okay, t naught second, delayed output. And if y of t is equal to yb of t, then the given system is said to be, if ya of t is equal to yb of t, ya of t is equal to yb of t, then the given system is said to be time invariant. The given system is said to be time invariant. Time invariant system, otherwise it is time variant system. Okay, this is the procedure to check whether the given system is time variant or time invariant. Got it? Now let us solve some examples based on this. Let us solve some example. So let us try very first example. Very first question, check whether the following system is time variant or invariant. Like first example is y of t equal to x of 2t. First, see the procedure. First, find output due to delayed input. So delayed input means simply you have to replace x of t with x of, here delayed input means find the output due to delayed input ya of t, x of this input signal is delayed by naught second. Simply you have to write minus t naught. input is delayed by t naught second. Input is x of 2t, it is delayed by t naught second, that is 2t minus t naught. Okay, this is number 1. This is the output due to delayed input. Now find the delayed output with the same shift. So yb of t, delayed output, that means y of t minus. Now left hand side, here left hand side you are replacing t with t minus t naught. Right hand side also everywhere, right hand side also everywhere t become t minus, yes or no. Left hand side t become t minus t naught. So right hand side also everywhere t become t minus t naught. So it is x of 2t minus, now compare 1 and 2 guys, y of t and yb of t. So as we can see here, ya is not equal to yb, so it is known as time. Ya of t is not equal to yb of t, it is known as time. This system is time variant. Okay, so it is a time variant system. Time variant system. Got it? Okay. So this is your time scaling guys. X of 2t means what? Time scaling. Okay. So time scaling operation, of course, it is what? Time variant. Now let us solve one question. Next question. Y of t is equal to x square of t. Tell me. Please first of all tell me this is linear or non-linear. Yesterday we have seen this linear system or non-linear system. Then check whether this is linear or non-linear system. Tell me this is linear or non-linear system. Non-linear system, yes, very good. Got guys. First of all, we can say non-linear. Now check whether this is time variant or time invariant system. Time variant or time invariant system. Tell me. Time variant or time invariant system. So first of all, find output due to delayed input. So x square simply minus t naught. Again, I am telling, I am not replacing t with t minus t naught. Simply minus t naught you have to write. This is number 1. Now, delayed output yb of t equal to y of t minus. Okay. So now here you are replacing left hand side, left of the equal to. So t become t minus t naught. So right hand side is everywhere. You have to replace t with t minus t naught. Now check 1 and 2. Check 1 and 2. Both are same. So that's why we can say the given system is time invariant system. Here we are getting ya of t is equal to yb of t. Then given system is known as time invariant. Time invariant. Time invariant. Known as time invariant system. Got it? Okay. Second example. The nonlinear and time invariant system. Very good. Now next question. Yes, Nikhil, you are right. Your answer is absolutely correct. Time invariant. Now tell me this one. Time variant or time invariant? Tell me whether this is the given system is time variant or time invariant system. Tell me in the comment box. time variant or time invariant? Okay, time variant, very good. Nikhil, yes, it is time variant system. This is time reversal operation. So first, find the output due to delayed input. So x of minus t, simply write minus t naught. Okay, number 1. Now find the delayed output yb of t equal to y of t minus t. Here you are replacing. Here you are replacing t with t minus t naught. Right hand side also everywhere t become t minus t naught. So y of minus t become t minus t. Correct? So it will be y of minus t plus correct, number 2. Now as we can see here, ya is equal to yb, ya of t equal to yb of t, then given system said to be time variant. Ya is not equal to yb, so time variant system. Correct? So again time reversal operation also. Time scaling operation x of 2t, and this is x of minus t, time reversal operation. Correct? Time variant. Next question number 4. Like x of alpha t. Alpha is any time scaling factor, like it is greater than 1, it can be less than 1, it can be positive, it can be negative also. It can be minus 1 also, guys. Correct? So simply alpha is a time scaling factor. So tell me, time scaling operation on input signal, time variant system or time invariant system? Tell me. So here, first of all, find output due to delayed input. So x of alpha t minus t number 1. Now delayed output, that is yb of t equal to x of alpha y of t, okay, y of t minus t naught, y of alpha minus, correct? So it will be y of alpha t minus alpha t naught. Now again you can see here, 1 is not equal to 2, the given system is said to be time variant. Ya of t not equal to yb of t, given system is said time variant system. Got it? Very good, Nikhil. Your answer is absolutely correct. So here conclusion is what? Time scaling operation, that means time expansion, compression, time reversal, whatever it is, always time variant. Now let us take one more question, like x of t square. X of t square. Now tell me whether the given system is time variant or time invariant. Tell me, time variant or time invariant? So first find output due to delayed input. So x of square minus t per 1. Okay. Now find delayed output is y of t minus. Okay. So replace x t with t minus t naught. Here t minus t naught whole square. Okay. As we can see here again guys, ya is not equal to yb. Here ya of t not equal to yb of t. Y of t is not equal to yb of t. Again, this is also time variant, correct? Time variant. Now here t become t square, again time variant system. Fine. This is what? Time variant system. Next question. Next question. Try this question. Y of t is equal to x of t minus 2. Whether this is a time variant and time or time invariant. Tell me. Time variant or time invariant. And I am expecting answer from each and every single student. Delay operation. Time invariant. Okay. Ya of t equal to x of here t minus 2 t minus per 1. Now find the delayed output y of minus t minus t. Simply replace t with t minus t. Replace t with t minus t. So if you are replacing t with t minus t naught minus 2, correct? Replace t with t minus t naught. Now compare 1 and 2 and tell me time variant or time invariant. So as we can see here, ya is equal to ya of t equal to yb of t. So the given system is time in invariant, correct? Time invariant system, right? So time delay operation or even time advance also, guys. X of t minus 2 like x of t plus 2 also time invariant system. Okay, time. Now next, t into x of t. So previous conclusion is what? What is the conclusion from the previous questions? The conclusion is, important conclusion, if you are changing the independent variable t, changing means what? If you are performing any operation like time scaling, time reversal, correct? Or you are replacing t with t square, all are what? Time variant. That means what I am saying, for one observation, y of t is equal to x of alpha t, time scaling operation. Alpha can be greater than 1, less than 1, positive, negative, it can be minus 1 also, correct? So always in this case time variant. And if you are performing any operation, time variant, if you are performing any operation like t square, t cube, root t, correct? Like square, this independent variable t, if you are performing any operation on t, guys, independent variable t, and the bracket t, like alpha t square, like e power t, like sin t, correct? If you are performing any operation this independent variable t, always time variant, always time variant system, like t power n. Suppose you are writing y of t is equal to x of, tell me, e to the power t, x of e to the power t. So again t become e power t, t become e power t. Given system is what? Given system is, in all the cases, given system is time variant. Into the bracket, if it is a function of t, to the bracket it is a function of t, alpha t, t power n, e power t, ln t, sin t, function of t, then always time variant, time variant, time variant system. So remember this thing, you have to write in the short notes. SN means short notes. Now this question, 7 number question. So number 7, y of t is equal to t into x of t. Tell me whether the given system is time variant or time invariant. Time invariant system, sure? Tell me, this is time invariant or variant? Let us check. Y of t, y of t, first food is delayed by t naught second. So t become minus t per 1. Now output is delayed by same t naught second. Replace t with here. See this t become t minus t naught. So right hand side, so everywhere you have to replace t with t minus t naught. So here t become t minus t naught, and here also guys, here also x of t minus per 2, correct? Number 2. Now check 1 and 2 guys. Check 1 and 2. So ya of t is not equal to yb of t. That's why given system is time time variant system. Here, what time variant system? Still clear? Now, number 8, x of t into sin t. Number 8, x of t into sin t. Tell me, this is time variant or time invariant? Time variant or time invariant? Why we not scaled t with t naught? T become t minus t naught. T with naught. Okay. Here you have to find output due to delayed input. So you have to delay operation in input only. Correct? You have to do the delay operation in input only. Correct? This is what is the function of t multiply with input signal. Any function of t which is multiply with input signal. So just you have to find first output due to delayed input only. First of all, perform the delay operation in input only. Okay, and next is what you have to find the output, delayed output. So here left hand side t become t minus t naught, right hand side also everywhere t become t minus t naught. That's why. Got it? Okay, very good. Next question, similar question. Tell me. Here also one conclusion I will provide. Time variant or time invariant? Time variant or time invariant? So first of all, find output due to delayed inputs. Sin t is any function of t multiply with x of t. You have to just delay. You have to just perform delay operation input only. Input only. See here, delayed by t naught second. Here this is sin t. Sin t. Now delayed output. Delayed output y of t minus, left hand side t become t naught, t minus t naught, right hand side also everywhere t become t minus t naught. Here also t become minus. Correct? Now you can see here, you can check ya is not equal to yb. That's why here again we can write ya of t not equal to yb of t. The given system is time variant. So the important conclusion is what? If function of t is multiplied with input signal, any function of t is multiplied with input signal, the given system again time variant. Here also in previous question just we have seen t is multiplied with x of t. This question also x sin t is multiplied with x of t. Correct? That's why time variant system. So here one more conclusion you can add, number 4. If any function of t f of t, nothing but function of t is multiplied with input signal x of t, then also given system is said to be time variant. What? Output signal, your signal, and this is any function of t, any function of t. Here, so if input signal is multiplied with any function of t, this case also always the given system is time variant system. All these 5 cases, given system will be time. This conclusion is very much. Now let us take one more question. Tell me, is time variant or time invariant? Nikhil Misra, tell me, time variant or time invariant? Time variant to time invariant, tell me. So again see, again you can see function of t, but function of t is multiplied with input directly we can say system is time variant. One system is said to be time variant. Clear? Very good. Now next, question number 10. Y of n is equal to 3x of n minus x of n minus 1. Time variant or time invariant? Time delay operation and time advance operation will not affect the time invariant of the given time invariance of. Tell me, 3x of n minus time invariant. Very good. See here, there is no change in the independent variable. Here also there is no change in the independent variable. So looking by this only, we can say one system is time. Here n, here also n. Time delay operation doesn't alter time invariant. Now number 11. Tell me, y of t is equal to e power x of t is time variant or time. This is of course non-linear system. Time variant or time invariant? Very good. Time invariant. See here. Here also only t, guys. Correct. And this is only t. There is no operation performed on the independent variable time t. That's why this is also time variant. Linear or non-linear? Linear or non-linear? Of course, e power x of t. Linear, non-linear system. Correct. This time invariant and non-linear system. Fine. Here. Next question. The next question. Tell me, this is time variant or time invariant? Time variant, yes, of course. Time reverse operation. Time variant system. Very good. Time variant system. Correct. Time variant system. This is qn minus k. Time variant or time invariant? Qn minus k. Where our independent variable is n, and k also one kind of variable, it is the value only. Variant or invariant? Time variant or time invariant? Tell me. Okay, so this is time variant or time invariant? Yes, this is time variant system, because here see time scaling operation, decimation, That's why time variant system. Next, number 14. Cos of x of n. This is linear or non-linear? Of course, this is non-linear system. Okay. Now, tell me, this is time variant or time invariant? Time variant or time invariant? Time variant or time invariant? Of course, here, yes, very good. Time invariant and only time variant. Next question, question number 14. Summation operation minus infinite to n. Summation minus infinite to n x of k. Time variant or time invariant? Tell me in the very much important. Summation is from minus infinite to n. Is minus infinite to n. Summation is minus infinite to n. So time variant or time invariant? Time invariant, tell me. See, y of n, the different values of k, x of minus infinite plus x of like and so on, minus infinite, starting from minus infinite. Last term is x of, correct? Yes or no? So as we can see here, there is no time scaling operation, no time reverse operation, correct? Perform the independent variable indicates what? Time invariant system. Summation is minus infinite to n, here at n. That's why time invariant, not time variant. This is time invariant. This is time invariant only, correct? Time invariant, correct? As you can see here, summation minus infinite to n only. That's why, correct? Similarly, this question. Now see, summation minus infinite to 2n. Now upper limit is 2n, minus infinite to 2n. Is time variant or time invariant? Lower limit is minus infinite summation. Last is k equal to 2n. Now tell me, y of n equal to x of 2n. Time variant or time invariant? Y of n is equal to x of 2n. Tell me, this system is time variant? Yes, now it's a time variant because of this system is time variant system. Correct? Time variant system. Because of this, it's time variant system. Fine. Okay, next. Similarly, integration minus infinite to tau, guys. Minus infinite. Tell me, minus infinite to t. Here t only. That's why it is time invariant system. Correct? Only t. That's why time invariant. Here only tau. But suppose I am writing minus infinite to t by 4. Minus infinite to t by 4. Because of this, tell me. System is write in the comment box. It is the time variant system. Okay, very good. Time variant. Okay. Now, next classification is causal and non-causal system. Okay. So, how to identify whether the given system is causal or not? So, if system, if present output of the system depends only on, a system is said to be causal, or we can say a system is said to be causal if present output of the system depends on present input and past history of the system. Past history means past output or past input. If the present output depends only on present input past input and past output of the system, then it is said to be causal. Otherwise, it is said to be non-causal. That means if the present output depends on future input of the system, the present output depends on future input of the system, then it is said to be non-causal system. See here, a system is said to be causal if present output depends only on present input and past history of the system. Past history means past output and past input. Present output depends on future input of the system, then it is said to be non-causal. So see here some important concept. Present time you can take any. If you want to take t equal to 0 present, you are taking t equal to 0 is present, guys. You are considering this is your present time, correct? If this is your present, then right side of this all are what, like t equal to 1, 2, 3 or t greater than 0. So t greater than 0 here in this is your future time, yes or no, or future time, right side of this, and left side is nothing but your t less than 0. Left of this is nothing but your past. Left hand side is your past, yes or no. Right hand side is future, left hand side t less than 0 is your past. Now it is not necessary to take t 0 as a present. You can take any instant as a present time. That means suppose if you want to take t equal to 1 or 1.5, suppose you want to take t equal to 1 or 1.5 or 2, 2.5 as a present time, you are considering your present time, then with respect to this all the right sided value are future time, yes or no. Right side of the, that means t greater than 1 the future or future input, and left side of this t equal to 1, that is t less than 1, your past time. The similar way, suppose if you wants to take t equal to -2 present time, suppose you want to take t equal to -2 as a present time, with respect to t equal to -2, right side of t equal to -2 will be your future, and with respect to t equal to -2, left hand side all the values are your past values. If this is future, present, respect to this or past. Here, okay. Now let us solve some question that you can get the more idea. Check whether the following system is not time variant, is causal or non-causal. Now let us check whether the given system is causal or not. Now let us consider first t equal to 0. You are considering t equal to 0 is your present. So at t equal to 0, you want to find your output. T equal to 0, guys. Equal to 0. Y of 0 will be your present. Correct? Present. So y of 0 is equal to x of y of 0 is equal to x of 0. So as t equal to 0 is the present, also your present input. is your present input, your present output. Now suppose t equal to 1. So consider t equal to 1 your present, correct? This is the present output. Present output. Okay. And for this you required input present at t equal to 2, at t equal to 1. So as if your t equal to 1 is the present, with respect to t equal to 1, t equal to t equal to 2 is your future. So this is your future input. So present output depends on future input of the system. So that's why now we can say the given system is non-causal system. But it given system is said to be non-causal system. You cannot say partially it is causal. If any one condition is fail for any instant of time, the condition is fail, then it is said to be non-causal only. Non-causal system. Okay. Non-causal. Here, Nikhil Mishra, tell me, clear or not? Minus 1 is your present output, then also no issue. Suppose you are considering, suppose you want to take t equal to minus 1 is your present. Okay. So y of minus 1 is equal to x of minus 2. Yes, here you can say the present output depends on past input, but for this the condition is fail, that's why overall the system is non-causal, correct? Of course here you can say this is your present or present output, and with respect to this your past, correct? Past. So of course this case it is causal, but not, it should be causal for all the time, it should be causal for any instant of time t. Okay. This is clear. Next, you tell me what about this x square of t, causal or non-causal? Tell me whether this is a causal or non-causal system. You can take one positive value, you can take one negative value, and you can take t equal to 0. With the help of three values you can cross verify. Here also I will provide you shortcut. Y of 0, x square of 0, of course present input depends on present output depends on present input. T equal to 1, y of 1 equal to x square of 1, again present output depends on present input, and y of minus 2 equal to x square of minus 2, correct? So again present output depends on present input. So tell me, this is what? Tell me, Nikhil, this is causal or non-causal? Of course, causal system. Yes, it was a non-causal, causal, correct? Okay. Now next, check this x of minus t, time reversal operation. Time reversal operation makes system causal or non-causal? X of minus t, causal or non-causal? Tell me whether the given causal or non-causal. Non-causal, very good. T equal to 0, y of 0 equal to of course x of 0. Present output depends on present input. Now t equal to 1, y of 1 equal to x of minus 1. Now if t equal to 1 is your present, then t equal to minus 1 will be your past. So present input depends on the past input. But suppose if you are taking t equal to minus 2, wants to find output at t equal to minus 2, then for that required input present at t equal to 2. So if t equal to minus 2, t equal to minus 2 is the present and t equal to 2 will be your future. So present output depends on future input. That's why the given system is said to be non-causal. Non-causal. Next question, question number 4. X of alpha t. Now time scaling, whether it is time expansion, time compression or time reversal. Tell me, x of alpha t, causal or non-causal? Here we have seen first question, time compression, x of 2t is a causal or non-causal system. This is time reversal, non-causal system. Now suppose time expansion, suppose y of t, just example, x of t by 3, because for alpha greater than 1 and alpha equal to minus 1 already we have checked. Now let us consider alpha less than 1. Tell me, causal or non-causal? So again, suppose y of 0, then it will be x of 0. Of course, present output, present input. Now y of suppose minus 1, t equal to minus 1, then it is minus 1 by 3. So this is minus 1 and this is minus 1 by 3. This is. So you want output at minus 1. For that you require input present at t equal to minus 1 by 3. So the given system is said to be what? Present output depends on the future input. The given system is said to be non-causal system. Correct? Non-causal. non-causal. Said to be non-causal system, not causal. It is a non-causal system. Still, but it so x of alpha t, always non-causal, like time variant, correct? Same case here. Time scaling operation on input makes the system time non-causal system. Okay, whether it is time expansion, time compression, or time reversal. Now t become t square. In this case, tell me, causal, non-causal. Tell me, the given system is causal or non-causal. Whether the given system is causal or non-causal. Tell me your answer in the comment box. Whether the given system is causal or non-causal. Value of 0, of course, output depends on the input. But suppose if you are taking 2, then it will be x of 4. So present output depends on future input. Present output depends on future input. That's why given system is said to be your present output. Present output depends on future input. That's why given system said to be non-causal. Yeah. Now next, in the similar way, t minus 2, that we will cover in the next class. Time delay, time shift, time advance, that we will see in the next class. Okay, we will continue the next class. So all of you, thank you so much watching me live on Wallah English channel, and please provide your valuable feedback after completion session. And the next part will continue. So guys, next part we will continue subsequent module. Thank you guys.